Now we are going to see about the semaphore implementation part. Okay, we already know about operations, wait and signal. Wait is act as a intersection operation and signal is act for the exit section operation. Okay, now for example P1, P2 and P3, right? Some n process will be want to execute the critical section. So what is the procedure? Now I am maintaining that some queue. So what is the need of this queue? This queue is act as a waiting queue. So in this waiting queue, I place some more processes inside of the queue. Okay. Now first the process P1 executes the critical section. So the value S is assigned for process P1. P1 come and value S is equal to 1. So it will be assigned the value 1. So next it will be come S dot value less than decremented. So decremented means S value is changed into 0. If it is 0 means, check the condition, S dot value less than 0 means, or less than or equal to, okay, less than or equal to 0 means, less than or 0, right, the condition is correct. The condition is less than 0 means it will be, stop, and we are going to see about the semaphore implementation part. Two more functions are introduced here. The first one is block operations. First operation is block operation and second one is wake up operations. So what is the need of block and wake up operation? The block operation is used to place the waiting process in the waiting queue. So for example, say that S value is less than S value is 1 means it will be going to the critical section. If S value is decremented by particular process P1. Okay. Now P2 is come. I want to execute the critical section means we will check the value. If it is less than 0 means less than or equal to 0 means it will be automatically placed into the queue. So this waiting queue is used to place the waiting process in the queue. So that is done by the operation block. So block operation is used to place the waiting process. That means some process may be trapped out by this condition. So this process P2, P3 and etc. These operations, this process will be placed in the queue for execution process. Okay. Then whenever its condition is changed into, for example, S value is changed into 1 for particular P2 means it will be wake up from the particular queue. That is done by the wake up operations. So for example, process P1 is executed now, it will be assigned and executed into critical section. After completion is critical section, it will be go to execute the signal operation. Okay, signal operations means now the S value is set to 0. So it gives a chance to another process. For that reason, it will be incremented the value S dot value plus plus. So automatically this value changed into 1. Now check this value less than or equal to 0 means for any other process. For example, two processes are coming P1 and P2. So P1 whole S1 equal to 1. Now so automatically the P2 value is equal to 0. So this P2 value is, now check the condition S dot value less than or equal to 0. Yes, the P2 semaphore value is 0. So it automatically wake up from the waiting queue because P2's S value is not equal to 1. For that reasons we are going to place the process into the waiting queue. So for whenever the process P1 executed the signal operations means the waiting process will be wake up from the queue for the execution of its critical section. So it is done by wake up operations. So we in this part we have discussed two main operations, block and wake up. The block is used to place the waiting process in the waiting queue. At the same time wake up is used to wake up, that means to pick from or fetch from the process for the critical section execution. Next we are going to see the semaphore types. What are the types of semaphores? That is divided into two main types. First one is binary semaphore and second one is counting semaphores. So counting semaphore means the S value, integer value may be categorized from minus infinity to plus infinity. But in binary semaphore, the S value categorized into 0, either 0 or 1. because it's a binary variables. Okay, the binary semaphore use the synchronization hardware. It's very simplest one, at the same time very simple one, at the same time we use the synchronization hardware for its execution. That means the synchronization hardware is used this binary semaphore variable concept for synchronizing the process. Next we are going to discuss about examples for synchronization process, synchronization tool or semaphores. Okay, out of examples, the first one is reader writer's problem. First problem. And second problem, bounded buffer problem. Third one is producer consumer problem. The fourth one is dining philosopher's problem. And fifth one is barber shop problem. Sixth one is cigarette smoking. So, lot of problems are there. This semaphore is applicable. This semaphore is applicable for any suitable problems. Usually, the classical problems are divided into three main types: classical synchronization problem, less classical synchronization problem, not classical synchronization problem. For your related to critical section problem example, the semaphore is suitable to execute the process. Now we are going to discuss about the readers and the readers writers problem. See that. First of all, you note down the conditions. What you mean by what is readers writers problem? What's the actual problem is take care. So see that is a content. Now the reader wants to read the content and also writer wants to edit the content. So when at first the reader read the content means two more conditions are checked here. That means one reader is reader means it will be allowed to another readers or 2 or 3 etc. But at the same time the reader should not allow any writers to edit the content. So as per the reader's view, the readers allow other readers to read at the same time, does not allow any writers to edit the content. Now see the writer's problem. Now the writer go to write the content means it also take the two conditions. It should not allow any readers and also it should not allow any writers when the one writer edit the content. But readers are allowed here, but writers are not allowed when the readers are read the content. But in the writer's position, the readers and all as well as writers also not allowed to when the one writer edit the content. So this is the first condition. We will be use the three types of semaphores. So what are the semaphores means? At first, reader use RDR semaphore value. Okay, the writer use RWRT. This is semaphore value. Another one is read counter. So using the three semaphore values, reader, write and read count semaphore value, we are going to execute without any long wait process of execution of critical sections. Okay, moreover, the semaphore is used to avoid some more process like that long time waiting process. Already say about that some process are trapped out by some conditions in wait and wait sections. So these types of long waiting process, the process are waiting into, now the P1 is executed means, in executing process means the P2 and the P3 must be waiting in this section. This types of long time waiting create the problem is called deadlock. So one or more process waiting for its execution, waiting for the critical section part of execution and waiting in the queue, that is maintained by the block operations and wake-up operations. So this types of long time waiting at the end create a deadlock of problem. Next. Now we are going to see about one example, readers writers problem. Already we have discussed the reader have a two semaphore values, RDR and read count. The writer have a WRT. So two structured problems are here. Writers have a separate structure for its execution and the readers have a separate structure